So in order to be able to interpret our control charts, we're going to need some pretty specific definitions of accuracy and precision. And we're going to need to look at how those change over time. So accuracy is defined as being as close to the target as you can, where precision is defined as reproducibility. So when we're looking at a control chart, these show up in different ways. We are accurate if the center line of our control chart is near where the process requirements demand that the average be. And precision is a measure of how far apart the control limits are. So the closer they are, the more precise our process is. And it's important to recognize that when we see either a problem with accuracy or a problem with precision, the way that we go about trying to address the problem is going to depend on which of those types of errors we have. In order to really understand these topics, we need to understand a concept called the underlying distribution. Remember, whenever we're gathering data, what we're doing is getting a random sample from some population. The underlying distribution is the theoretical distribution that most closely matches what we see in our random sample. So the inference that we make from the random sample to the underlying distribution essentially is us looking at that random sample and trying to understand what would be the parameters of the entire population. There are statistically valid ways to do that, which we will study. And when we do that, we'd like the extremes of that underlying distribution to be within our tolerance limits, and we like the peak to be at the average that our process requires. So one way to think about precision and accuracy is to think about shooting at a bullseye. If we are precise, then our bullet holes are all near each other. And if we are accurate, then our bullet holes will be near the center of the target. So if you look at the graph of the underlying distribution for that set of points, it is centered on the center that you were aiming at, and its variance is relatively small. If we have precision without accuracy, our points will still be close to each other, but they aren't centered on the center of the target. And in the underlying distribution, that means that our variance continues to be small, but our center is not centered on the target that we were hoping for. If we have accuracy without precision, then our data is centered correctly, but the variance is too large. In our control charts, this means that the center of our data will be centered on the target that we were hoping for, but the variance will be too large, and that means the control limits will be too far apart to meet the requirements of the process. If we have neither precision nor accuracy, then the bullet holes are not centered on the center of the target, and they are scattered very widely around. In our control chart, this means that the center of our data will not be at the center that our process requires, and the variance will be large, so the control limits will be far apart. This concept of the underlying distribution is kind of fundamental to what we mean when we say the process is in control. So this chart is showing that we gather data in groups over time. Each of those random samples represents an underlying distribution. If our process is in control, then each of those samples is represented by the same underlying distribution. So the shape of the underlying distribution is the same as time progresses. Each sample makes the same shape for the underlying distribution. So the reason that this is important is that if the underlying distribution stays the same from one sample to the next, then we can use that underlying distribution to make predictions about what we'll be able to do in the future. When our system is not in control, then the samples that we take will not all have the same underlying distribution. Each of those changes in the underlying distribution is assignable cause variation. And assignable cause variation can affect either precision, or accuracy. As shown in this chart, sometimes the center of the curve might move away from the center that you are hoping to meet, or the variance might change, and in fact, it might even become asymmetric. These are all changes in accuracy or precision. You can see from this chart, if the accuracy and precision are changing, the process is out of control, and that means that we can't make any predictions about the future. So the first thing that we're going to have to do is fix the assignable cause variation so that our process has a reproducible underlying distribution. At that point, accuracy and precision will be repeatable, and then we'll be able to look, do they meet the requirements of the process?